Hello everyone, my name is Sanford, and my final project in Engineering 1050 is a Python rail simulator. This project simulates a rail line with both local trains that stop at every station and rapid trains that only stop at designated rapid stations. So having these two different types of trains on the same line complicates things. You'll have trains moving along the line faster than others, so you're going to have to figure out a way to prevent collisions from occurring. So before I show you guys the simulator or the simulation, I'm going to go over an overview and some conditions. So local trains are blue and rapid trains are red. Local stations are plotted as circles and rapid stations are plotted as rhombi. This track is supposed to be a loop. So once the train reaches the end, it comes back to the beginning. And to prevent collisions, there's many different ways you can think about or achieve this, but I was inspired by what I saw with bullet trains in Japan. So if a local train is held at a local stop and a rapid train is approaching close by from behind, this local train will remain held at that station until a rapid train passes through the station and clears out up ahead. And then that local train can start moving again. This is under the scenario that local trains have bypass rails for passing rapid trains to use. So as you can see in this image right below, you'll have an additional rail in the center of the platform where, well, separate from the rail right next to the platform. So a rapid train can pass through a station without colliding with a local train being held there. Now this time becomes tallied up as wasted time that trains must be spent waiting at stations. So this is a useful variable that I'll talk about later, which allows you to see just how efficient your rail line is compared to others. And if a local train is held at a rapid stop and a rapid train is approaching from behind, it will not be held for extra time because that rapid train will need to stop at that station as well. So in a basic sense, in order to prevent collisions, you just don't want trains to stop at stations at the same time because this is not possible. So hopefully you guys will be able to better understand the system now that you have a little bit of an overview. So let's go into the project itself. So up at the top or near the top, you have a few adjustable variables. And you'll also want to list out your stations and trains. Let me go over this real quick. You have a frame count here. This controls how long you want the simulation to run, interval. This controls how fast you want the animation to update and run for. So a lower number is faster. And then here you have a stop length and a crash distance. Stop length is how long each train will spend stopped at a station by default. And crash distance controls the distance threshold for holding a local train at a station. So it controls what distance will require the local train to be told to hold at that station instead of going to allow the rapid train to pass through. And unfortunately, I didn't do any fancy app development or user interface work. So you will have to list your stations and trains manually right here. So let's get right into the simulation. I'm gonna run it at a fairly slow interval so you guys can all see. So here you have it. You'll be able to see local trains being held for rapid trains passing through. So maybe like right here, you'll see rapid trains passing through. Maybe again soon with this one. But up here, you'll see two tallies or see the local train being held. But you'll have two values being tallied up right here. The total stop time, which adds together all the time that all trains spend stopped at stations. This includes both the default stop time and the additional held time. And then the wasted time below is a much more useful value, which tells you how much total time trains have been held at stations for additional stop time. So you'll be able to adjust parameters and then compare their wasted time values to determine which set of conditions for a rail line make it more efficient, which I think is very cool and useful. All right, so for this line right here, this scenario, we had a wasted time value of 318. Let's remember this. Now, let's change some of the parameters up a little bit. Let's say that we have high passenger usage over here and very high demand, very much high crowding. So we want to add an additional local train up here. So let's add it right in the middle of this red and purple station right here. Let's close up the simulation. And let's create a new station. So I'm going to list it out under all the others and call it Ikebukuro. And call upon this class. And we're going to give it a position value of 130. We're going to make it a local stop. All right, so now that we've set it up, we can just run the simulation and you'll see that it's become this purple, there's pink dot right here. So I believe the wasted time value from the last simulation was 318. So let's see what it turns out to be this time. So I'll dive more into it later after we change some of the parameters up. But this project runs heavily on object-oriented programming. The stations function as classes and the trains function as classes, each with their own methods, which allows them to act as they act. All right, this time our wasted time value increased to 386. And that's understandable. When you add a station, inevitably all you're going to do is increase the total amount of time trains will have to be stopped at station. You'll have more opportunities for trains to be held at stations to prevent collisions. But upside is you have more relief in this area and more places for passengers to get off on. So you have to weigh those benefits in those cases. So let's try to optimize this line a little bit. I see here that we only have realistically 2 rapid stops, because remember this one serves as like one station because it's a loop. So let's add or convert one of these stations into a rapid one. I say let's turn this one to a rapid one right here, which I have as named Mejiro station. So let's turn the station from local to rapid. And let's run the simulation again. This time, let's decrease the interval since you guys are now a little more familiar with the simulation. So we can run it quickly. As you can see, the circle turned into a rhombus because it is now a rapid station. And I believe our wasted time value was like 384 or 386. I forgot which one. But let's compare and see if it's changed this time. All right, simulation ended, and we can see a significant decrease in the wasted time from 384 to 314. So this is just because rapid trains, you don't need to hold local trains still at these stations anymore because the rapid trains will need to stop at them as well. So we can see that this might have been a very smart choice of this rail line. You're saving a lot of wasted time. Let's try to optimize it even more. I can see here that we have rapid trains that seem to be running very close to each other this whole time. So let's try to spread them out a little bit, see if that changes anything. Because I see a lot of instances where local train have to wait for 2 rapid trains to pass through instead of just one. So let's maybe just switch some of these trains too. So let's change this train that starts at Meguro from a rapid one to a local one. Let's change this train that starts at Shibuya from local to rapid. Let's see if this changes or decreases the total wasted time. Additionally, you could add trains to different parts of the line as well, see if that changes anything. But with a demo line this small of the scale, I don't know if I would want to add another train to make it would make it very congested. But realistically, you'd have a line much larger than this, and you'd be able to experiment with that. Oh, wow. So we can see the wasted time decreased from 239. So just two versions ago, like if you want to call it that, we had a wasted time of like 384. So you're able to decrease it significantly just by changing one station to a rapid station and changing or switching the locations of a rapid and a local train. So as you can see, you can use this simulation to test some things out, and it can be very helpful for rail planning by calculating the efficiency of the rail based on this waste time value right here. So before I end, just show off the code a little bit, but like I said earlier, it's dependent on object-oriented programming. In many ways, very similar to our last assignment in Engineering 1050 with the random moving walkers. But you have a class for the train, which has its own methods. So let's go, loop, stop, then crash, which is what prevents clashes between trains. And you have a class for stations, which is much more simple. As you can see, I use the func animation along with an update method, which basically just runs all of the train class methods within this every iteration to allow this animation to occur and everything to come together. So I hope you guys enjoyed seeing this demo, and I hope you find this project concept as interesting as I do. And thank you for watching.